Hello, and welcome to this presentation, Understanding Directional Power Measurements. This presentation provides a basic introduction to directional RF power measurements and the most commonly used devices for measuring directional power. This presentation assumes a very basic understanding of voltage standing wave ratio and return loss. If you're unfamiliar with this topic, or if you'd like a brief review, you might want to watch the presentation Understanding VSWR and Return Loss before beginning this presentation. Let's start by reviewing terminating, that is, non-directional power measurements. Most RF power measurements are made using a power sensor, which terminates the signal. That is, the sensor is connected to the power source and, ideally, absorbs all of the incident RF power. Note that this requires a good impedance match between the source and the input of the power sensor. RF power sensors are not normally frequency selective, and therefore they measure all of the power within their bandwidth. This measurement is reported as a single scalar value, most often in units of either dBm or watts. RF power sensors typically interface with either a power meter or base unit, or they may interface with a PC over a USB or LAN connection. Some test and measurement instruments, such as spectrum analyzers, VNAs, etc., may also support a directly connected power sensor. In a directional power measurement, the measuring device is inserted between the source and the load. This allows measurement of both forward power and the reverse or reflected power. In most cases, these measurements of forward and reverse power are made simultaneously. These two quantities can also be used to calculate the load impedance match, which is commonly expressed in terms of SWR or return loss. Directional power measurements are used during system installation, for short or long-term monitoring of transmitters, and during troubleshooting. In all of these applications, it's important that the measuring device have a minimal impact, and this in turn requires a good impedance match on both sides of the measurement device, as well as very low attenuation through the device. Now let's go over the three types of devices that can be used to measure directional power: unidirectional wattmeters, bidirectional wattmeters, and both terminating and directional power sensors. We'll start with unidirectional wattmeters. A unidirectional wattmeter, such as the one illustrated here, measures power in only one direction at a time. Typically, the frequency range and maximum power that can be measured by these types of meters are determined by removable elements, or slugs, and in some cases, this element or slug can be rotated 180 degrees to enable measurements in the reverse direction. However, most of these wattmeters only measure average power, although there are some meters that can also measure peak power, often by means of an additional internally installed board. One of the reasons why these devices are called wattmeters is that they display power in units of watts. A different type of wattmeter is the bidirectional wattmeter, which can measure both forward and reverse power simultaneously. These powers are often displayed in the form of crossed needles, one showing forward power and one showing reverse power. The point at which these needles intersect can then be used to read standing wave ratio from a scale printed on the display, and therefore bidirectional wattmeters are also commonly referred to as SWR meters. Many of these meters can also natively measure both peak and average power. These meters are often left in line during normal operation in order to allow continuous monitoring, particularly of SWR. Another method of measuring directional power is using a directional coupler together with terminating power sensors. A terminating power sensor is attached to the so-called couple port for each direction of the directional coupler. One terminating sensor is used to measure forward power, and another terminating sensor is used to measure reverse power. The attenuation at each couple port, typically on the order of tens of dB, must also be taken into account. In a dual-directional coupler arrangement, such as the one shown here, power can be measured in both directions simultaneously, and standing wave ratio, return loss, etc., can be manually calculated from these values. It's also possible to make unidirectional power measurements using only a directional coupler and a single couple port. The coupler would need to be reversed, and/or a second unidirectional coupler would be needed in order to measure power in both directions. The last category of measuring devices we'll look at are directional power sensors. These are similar to terminating power sensors, but have two ports, enabling them to measure power in both directions simultaneously. These types of sensors also provide both the highest accuracy and the greatest flexibility when making measurements of directional power. Similar to the principle we just discussed on the previous slide, these sensors are a combination of two high-accuracy RF detectors and a dual-directional coupler or reflectometer, and thus they can calculate and display impedance match values such as VSWR in real time. In addition, more sophisticated measurements such as burst power, peak envelope power, and CCDF are also supported. These types of sensors can often be programmatically controlled, enabling both automated measurements as well as remote access. And finally, many of these sensors also support external event triggering, making them easy to integrate into more complex test and measurement scenarios. Let's end with a brief summary. Directional power measurements are made between a source of RF power and a load or sink of RF power. That is, the signal is measured as it passes through a device. This enables measurement of the amount of power in both the forward as well as the reverse direction. These measurements of forward and reverse power can also be used to calculate the degree of impedance mismatch between source and load, typically in terms of standing wave ratio or return loss. There are three classes of devices commonly used when making directional power measurements: unidirectional wattmeters, which only measure in one direction at a time, are the oldest and most basic devices still used for measuring directional power. Bidirectional wattmeters, on the other hand, can measure in both directions simultaneously, and because these measurements are often used to display standing wave ratio in real time, they are sometimes also referred to as SWR meters. Terminating power sensors can be used together with directional couplers to measure directional power, but dual-port directional power sensors provide the highest accuracy, functionality, and flexibility of all of these methods. This concludes our presentation, Understanding Directional Power Measurements. If you'd like to learn more about power measurements, related topics, or power sensors from Rohde and Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.